Welcome to Advanced Algebra 2 Summer Bootcamp Lesson 5. We have two documents here. I created that one. That's our linear inequalities lesson page. And then there's another one right there. Can I graph you two? Can I graph you two? Inequalz. We'll be checking out the Inequalz app using that activity. And we are starting with some notes. So let's see if I could organize my workspace here. Thanks for being here. Thanks for learning with me. And we're going to jot down some things. So, are you ready? Let's do this. I'll make myself smaller. This is great. Hope you're doing well. Okay. So linear inequalities, let's talk about this. The absolute value function. Now, you might be wondering, well, what's that have to do with a linear inequality? Isn't that an absolute value? And what I found in Algebra 2 and Pre-Calc is even though absolute value and inequalities are really not huge topics, like we talk more about continuous functions and a bunch of different curves and stuff like that, they tend to be ones that students get stuck on. So I think it's an important thing to look at. And one of the most challenging things is when we talk about absolute value inequalities. So that's our focus today. And the first thing I want you to know is what an absolute value function is. So the equation is y equals absolute value of x. And at this point, you know, many students going into Algebra 2 in whatever fashion pretty much know that if you take the absolute value of a number, it's positive. It's the distance from 0 on a number line. But here is the graph, and that's something that we're more concerned with in this lesson as well as in the future. So the graph goes right through the origin and basically looks like two lines. So that's where the linear inequality things come in. Is first of all, the absolute value function is basically two functions, the positive x and negative x, but kind of combined into one. So here's a positive x, negative x. I don't know if that perspective is good for you. Now, what about the absolute value function on the TI-84? Now, to get to that, to graph that, we press the math button and arrow to the right to num. So you see the picture that I have for you. You highlight num and you choose abs. Really working on our abs, you know what I mean? So then once you grab that, this is in y equals, by the way. You're in y equals, and you plug that in, and then you press zoom 6 or graph, and you have just a default graph of the absolute value function. Now we could transform absolute value of x. You know, it could be absolute value of x minus 4 or 3x minus 2 or different things like that. But we're just getting started. So let's take a look at the absolute value inequality. So once you know what the absolute value function looks like, you could start to work with what it is greater than or less than, you know? So the absolute value inequality, there are four different situations. Here they are. Y is less than absolute value of x, y is greater than absolute value of x, and less than or equal to, greater than or equal to. Now that y value, that could just be something that we're comparing to absolute value of x, like a 5 or a 7 or a 10 or a negative number. Now you can't enter these into your calculator as they are, but we could certainly solve them, which we'll do down below. You have to use an app called Inequalz, which is pictured on the right. Now you don't have to use that to understand the absolute value inequalities, but it's helpful. And it's kind of a new discovery of mine, so I wanted to share it. Kind of nifty. So to get there, we press the apps button and number 7. Now, if you don't have the most up-to-date OS on your calculator, then you won't have this app. So you have to go through that process. But most likely, if you bought a new calculator, then you have the app, or if you get one from your school. From me. So that's how you access that, and we'll use that in this activity coming up. Now, let's do a little bit of math together. I say a little bit of a lot. I like to do a little bit of stuff. I'm an incremental type of guy. I like to improve on things here and there. So, I'll do a little bit of my work at this time, and then I'll take a break, and I'll come back, and I'll do that. My chores, when I clean my room, I'll spend some time, I'll come back later. How about you? Do you do that? Some people are all or nothing. I'm going to do this whole thing right now and finish. So let's solve absolute value of x is less than 10. We're going to do the whole thing. Well, what that really means is that x inside the absolute value is either less than 10, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or anything in between, or it is less than negative 10 in a negative sort of way, meaning negative 9 works, negative 8, negative 7, negative 6. Okay, so what that looks like in algebra is x is greater than negative 10 or x is less than 10. So it's that greater than negative 10 that's kind of weird. When we say x is greater than negative 10, we mean it is something bigger, like negative 9, or less worse, So then we could get a little number line to show what the solution is to this linear inequality, this absolute value inequality. Now, when the absolute value is less than a specific number, then that's called a conjunction. Not a huge deal, but it's kind of helpful to notice that sort of thing. Now, when absolute value of x is greater than negative 10, it means that we're going to have two separate solutions that are disjointed, or it's a disjunction. So that means x is less than negative 10, meaning it could be negative 12 or negative 13. Because if we take the absolute value of negative 13, we get 13, and that's bigger than 10. Or x is greater than 10, just as is. So one of our inequalities that we always come to with absolute value inequality is just taking away the absolute value. But the mistake that students make is they don't consider the other side. So those two inequalities, and then we could do a number line with that and get the outside parts of the number line as solutions. So they're disjointed. It's a disjunction. And by the way, the open circle means that we don't include those specific values. So if it's less than or greater than, then we'll have an open circle. Okay, there we go. That's our algebra. That's our meat for today. I know if you're thinking about school, like we're just getting little bite-sized chunks. Now, how do we solve absolute value inequalities on the calculator? Well, we'll do that with Inequalz, but we don't really have to. There's a shade feature in y=, that we could use, and it just allows us to shade below or above a graph, and that helps us to see it visually. Or you use the Inequalz app, which we'll do. Okay, so that's the background information. The next thing that we'll do is work through the activity. I'll show you the Inequalz app and how to do that. And in this video, I'll actually just be doing full screen, just kind of switching things up here. So full screen of my calculator app so that you could just see that itself. So having the Can I Graph You 2 activity sheet out and jotting down some notes on that would be great. I'm just looking at my notes and I don't see, I don't write much on this sheet. So I think it's more important to see it's like a big graph. Okay, let's check it out. Can I graph you too? Let's graph stuff together. First, we're considering the equation absolute value of x equals 5. So to understand inequalities, it's helpful to understand equalities. So think about how the fact that if you plug in -5, you get 5. And if you plug in 5, you also get 5. So the absolute value of x is equal to 5 when x is equal to -5 or 5. Let's open the Inequalz app. So apps 7 press the any key. Just kidding. Okay, and so first example is we are working with absolute value of x is less than 5. So what we want to do is enter absolute value of x first. So math, num, abs, get this workout in, working our brains. Now that says y equals x. Okay, that's not the inequality. The inequality happens when we enter 5 down in y2, and to turn this equation off, we could press enter on the equal. That's not what we want. We move to the left and go here, and this is where you could change your shading. So if you arrow down, this is where you change the inequality sign. So let's make it less than or equal to. But then this is where you could change, like if you go down this style thing right here, you could change that without the Inequalz app. So that's kind of cool. Okay, so let's press OK. So enter. So now we have basically x, absolute value of x is less than 5. Okay. Now we are just going to graph this. So let's press zoom 6 for standard. And there you see in blue the absolute value function. And I want you to see right away, absolute value of x is equal to 5. So this is 5 at -5. This is -5. And 5 over here. And I could show you that with trace. I could go over to 5. Pretty close. Oh yeah, jumps right on. So that's pressing the trace feature, kind of common. Okay. Now we could use something that we already learned in a previous video. You could press second calc, second trace, and use the intersect option to actually find the intersection. So I'm just going to move this here so you can see. So first curve, enter. Second curve, it jumped. And then guess. So notice this is the first time we saw this together where there are 2 intersection points. So I want to go close to this point here, press enter, and there it is. To get the other one, we'll just do that quickly. Second calc intersect is 5. And notice we're on the first curve, so I press enter. We're on the second curve, I'm getting closer to -5. And then I'm closer to this point over here on the left. So I could press enter for my guess, and it gets the negative version. Okay. So on the actual TI worksheet, it just says press enter 3 times, but it all depends on where your cursor is. So the final thing I want to show you, and really what this app is helpful in seeing, helpful for us to see, is the actual solution. So press trace, and I want you to come over here to the left, and I want you to see that the absolute value function is greater than 5 up here. So it's up at 7 point whatever. So this x value, -7, is not part of the solution because we want less than. So, and I could jump to the other equation, by the way. y2 is less than 5. So notice by jumping up, the blue is taller, it's bigger, it's greater, but we want less than. So now I could go to this next window, which is kind of in this middle area, and I could see that y has a value of 1.8. But if I jump to 5, there it is, it's 5, it's greater. So I know that I'm in a location right now that's a solution to the inequality. And then the final space, this is still kind of part of the same space in this window here. The final space would be kind of over here. I jump up to the y1. Notice that again, this is, let me go to a different value. Let's say 8. 8 is definitely greater than 5. So we have like 3 windows. We have the left part, which is to the left of -5, and the middle part, which is in between -5 and 5, and the right part, which is to the right of 5. Okay? So therefore, our solution to this inequality is everything in the middle, which is between -5 and 5, but excluding those 2 values because it's an inequality that doesn't have the equal sign. And so like I said in the little background information, this is a conjunction because the solution is just one window. You're not creating 2 different spaces. Example 2. So let's go into y equals again, and we'll change the equation. So the first one, if you arrow right in x, you see that we have this little space we could type inside here. So minus 4, so x minus 4 is greater than or equal to 8. Let's change this to 8. And then we'll go into that space again. So we'll go to the left and press enter, arrow down, and choose greater than or equal to. And notice the style, like it has the top part, so greater than or equal to. Now I'll hit zoom 6 or just graph because I already have a standard window. And notice that my graph is now outside of this window that I would have liked to see. So it's kind of helpful to actually change the window here. So I'll do that. And notice, I don't know, I'm looking at this point here, 1, 2, 3, 4, 5, 6, 7, 8. So I want to go 1, 2, 3, 4, 5, 6, another few more at least. So let me change the X max to, oh, I don't know, 14. So there it is, we can see everything. Okay, now in a similar manner like before, we could tell, like if I trace this, I could tell the intersection point between the two graphs. So like this value right here, -4, 8. And so that's one thing we're doing. We're finding the intersection points, -4, 8. And then we could go all the way to the right. I'm just right arrow and holding. And 12, 8. So -4 and 12. So I know those will be in our solutions some way, okay? And the next thing is to do kind of what we did before. Let this graph, let this visual help us understand the solution. So when is x minus 4 absolute value greater than or equal to 8? So notice that if I go to the right here, here's one area that this blue line is greater than the red line, okay? So that's the space, like the cutoff. Anything greater than that point, that intersection point we looked at, which is 12, is part of our solution. So if x is greater than or equal to 12, that's one of the solutions. Okay, so there's the 12. Now if I go in this middle part, notice that all of the blue is less than the red. All this. So it's not part of the solution. It's less than 8. We want greater than or equal to 8. So this is still breaking point. And so these values up here are greater than 8. So kind of similar to the right side. So anything less than -4 is going to give us values for the blue graph that are greater than 8. Okay. So now I hope you could see that because the solutions are to the left here and to the right of over here, the solution is disjointed. So a disjunction. Hey, thanks for checking out the Inequalz app with me. The next best thing that you can do is check out these 4 exercises related to what we just did, approaching the problems with the calculator the same way that we just did. So don't forget, that process is number 1, enter the left side of the inequality as y1, right side as y2. Step 2, change the inequality based on the problem. Step 3, graph the inequality. And then step 4, change your window to make sure that you could see everything. Well, and then I guess step 5 would be to actually find the solution to that, right? Okay. Well, hey, thanks so much. And I'm looking forward to teaching you more stuff in topic 6. See you then.